Good morning, students. This is presentation 6, the last presentation. So we are continuing our mobile platforms presentation. Now, let us go to view in views in items. So we have said that you can design your application by drag and drop. Okay, all views or controls resides in parent. Then you can see parents. We have different types of views you can use in your application. The first one is common. Common is composed by text view, button, image view, cycler view, etc. Scroll view, switch. We have text view, we have buttons, we have widgets, we have layouts, we have containers, we have Google, we have legacy. Let us go to text group. Text group contains predefined text views for different types of text input. Okay, we can input is text, or we can display text by using different types of text views. So types of text views are displayed as follows. We have text view, plain text, password, dates, type, number, email. So these are all the different types of text views you can use when you are designing your application. Okay, you have to drag it depending on a type of data a user will provide. If it is a password, you have to drag and drop password text view. If the input will be date, you have to drag and drop the date text view, time, number, email, phone, and so on. So there are many. Let us see each in turn. Text view, which is the first text view. The text view is used to display text to the users, and this text information can't be edited by the user. Text view is used to display text which cannot be edited by the user. It works like a label, or yes, a label. It is provide instruction on what you can put in edit text, for example. Enter username, for example, that to display such kind of message, you need some kind of label. In our Android application, we call it text view. We have edit text, which is used to get text input from users. So you have to provide text input from users. We have plain text, which shows the standard text with keyboard. We have password, which shows the standard text keyboard. and mask the text. So it is password because it masks the text. You cannot see the content which is entered. Password numeric, it shows a numeric keyboard and masks the text that is entered for privacy. Then we have email, which shows the standard text keyboard. So this kind of input text, when you want to input it, it provides a specific keyboard depending on a type of data you are entering. So if it is a numeric text, so in that case, it will provide a numeric keyboard. If it is the input will be alphanumeric, it will provide a text keyboard. For example, email shows the standard text keyboard with addition of that character. We have a phone which shows a phone style keyboard. We have postal address which shows the standard text keyboard. We have multi-line text which shows the standard text keyboard with addition of enter key for adding a new line. So we talked about the time, which shows the numeric keyboard with an addition of the colon character, because when you are entering time, you need to, there is a colon separator, which separates hours from minutes, and the minutes is separated from seconds, and seconds can be separated from years by using the colon character. We have date, which shows the numeric keyboard with addition of the slash separator, because most of the time we have different date format, and each date format is having a different separator. And then month is separated from date by a given separator. We can use this slash, and date can be separated by year by another given separator. So it can be minus operator. Minus operator can also be used. So we have many types of separator for date. So for this one, it shows this slash separator. So we have number input, which shows the basic numeric keyboard. Number signed, it shows basic numeric keyboard and allows plus for negative character at the start. You can put a plus because it is signed. You can put a sign. A sign can be a plus or a negative. Numeric decimal, it shows basic numeric keyboard and allows a decimal point. A decimal point, because decimal numbers always have this decimal point to provide fractional values. Now, we can also have buttons. Buttons. So we have different kinds of button views. So button, image button, checkbox, radio button, radio group, toggle button, switch button, floating action button, and others. So we have also layout group view. Layout group views. We have a linear layout. It is horizontal. It can be horizontal. Linear layout, which can be vertical. We have frame layout. We have table layout, and we have grid layout. These are layouts. Layout, it is like arrangement of different views inside a container. Normally, when we are designing our application, so we have to drag and drop, or we have to write codes for a given view, and we are taking multiple views to make our application, and we are putting them into a container at a given arrangement we need. So arrangement of those elements is what we call layout. So the layout can be vertical, elements can be arranged vertically. The layout can be horizontal, so elements can be arranged horizontally. So we can use frame layout. So elements in that case are arranged in the frames, then table layout. So our elements in this case are arranged in tables, in the a table structure, table-like structure. We have also a grid layout where our elements are arranged in grids. So we have in layout group views, we have constraint layout. In 2016, Google introduced constraint layout as an alternative to linear layout and relative layout. Constraint layout requires the use of a library and it adds approximately 100 KBs to the size of your Android app. So we have a new type of layout which is introduced recently in 2016, and it requires a library. So because it requires a library, it adds an extra space to your Android application. So we have also a grid layout which was introduced in 2011. So Google added the grid layout to setting up complex Android layouts a bit easier. As the name suggests, this class allows chart views to be arranged in a grid layout, in the grid arrangement. So this is a layout where chart views, they are views that are put inside another view. And in the current view, we call it a container. So we can take a container view, and inside that container, we can arrange and put some child views and arrange those views by using a given layout. In this case, we are using a grid layout. Grid layout is a class. The grid layout class is optimized specifically for creating grid user interface design using a minimal amount of system memory. Okay, it will minimize the memory. It is one of advantages of grid layout, and it can render both horizontal user interface element and vertical user interface element alignment at the same time in the same user interface. So grid layout is grid, which is a layout which arrange child elements in a grid format. The grid format. The frame layout. The frame layout is a placeholder on screen that you can use to display a single view. If multiple child views are added, they will by default appear on top of each position in the top left hand corner of the layout area. So if this one frame layout provide buttons, placeholders on the screen that you can use to display a single view. You click, you display a view. You click, you display a view. So we have a linear layout which can be horizontal or vertical. So linear layout horizontal and linear layout vertical are actually the same layout with one property changed. It is we change the property orientation. Is the property orientation which can be changed to horizontal or vertical. The linear range is viewed in a single column or single row, depending on the orientation selected. Now we have relative layout. The relative layout enables you to specify how chart views are positioned relative to each other. Each view embedded within the relative layout has attributes that enable it to align with another view. So we can, before we open, let us first of all go through these slides so that we can make some practicals after. So the relative layout, which is a layout which enables you to specify how chart views are positioned relative to each other. Each view embedded within the relative layout has attributes that enable it to align with each other. So we have table layout groups, view groups views into rows and columns. So it arranges views in rows and columns to form a table view. So you use the table element to designate a row in a table. Each row can contain one or more views. Each view you place within a row forms a cell. Each view can form a cell, and when you put multiple views on the same row, you are creating, if you make multiple rows, then you are creating a table. The width of the column is determined by the largest of each cell in the column. So you are putting a view, and it becomes a cell. You are creating another view, it becomes a cell. So if they are arranged in the form of cell of rows and columns, then you are getting a table layout. So table view, the purpose of the table layout container view is to allow user interface elements to be organized on the screen in a table format consisting of rows and columns. Each row within a table layout is occupied by the table instance. So in a table, we have many table instances. So it is like a collection of table instances, which in turn is divided into cells. And a cell, a row, which is like also a collection of cells instances. So each row is divided into multiple cells, and each table is divided into multiple row instances, with each cell containing a single chart view. which may itself be a container with multiple view children. Now, containers, they are views that can contain other views. Scrolling view, horizontal scroll view, nested scroll view, view pager, card view, tabs, toolbar, tab layout, tab item. So the scroll view. So a scroll view is a special type of frame layout in that it enables user to scroll through a list of views that occupy more space than the physical display. The scroll view can contain only one chart view or view group, which normally is a linear layout. So you understand that we need a scroll view when we have more views, chart views which are not being visible to the display. And in that case, we need this scroll view to help us to scroll so that we can also view the elements or views which are not displayed. So it enables users to scroll through a list of views that occupy more space than the physical display. So we can have views that are occupying more space than the physical display. In that case, we need to scroll so that we can view all the elements. Horizontal scroll view can scroll horizontally, and by default, scroll view is vertical, which is used to scroll vertically. Android also has horizontal scroll view, which works like scroll view just horizontally. So a scroll view by default is used to scroll vertically, but we have also horizontal scroll view, which scrolls horizontally. Web view. The web view enables you to embed a web browser in your activity. So a web view, you drag a web view. In that case, your activity can use a browser. You can be connected to the internet and make researches by using this web view. This is very useful in your application if your application needs to embed some web content such as maps from some other providers and so on. The following slide out shows how you can programmatically load the content of the web page and display it in your activity. Container view. So we are continuing in container views. Among container views group, we have also a search view. So a search view in Android 3.0, Google introduced the search view, which can be included as a menu item when creating a menu. With this view, an expandable search area can easily be added to an application bar, action bar. This is a search view. So it is introduced by Google, and it can be included as a menu item when creating a menu. With this view, an expandable search area, is added to your menu of your applications. So we have also Google Container. Google Container has an add view and a map view. An add view it is used to display the banner for ads, and the map view is used to display a location with Google Maps. Now, creating an Android application. You create an Android application with the following output. So I didn't. There is a screenshot I didn't put here. So it is an activity. It is like an exercise. Okay, I didn't put the screenshot. I will give it to you. So event handling now. Okay, before we can go to event handling, let's see if our so I told you that you can write codes and run these codes either by using your smartphone, or you can use the ADD, Android Virtual Device. So let us see if our AVD okay, let us create a new one, new project. So let us call it for X7. Then next, empty, yes, next. Then main activity, yes. So it is still processing. Let us wait for it.